Hello everyone, welcome to part one of the robotic snowplow project. In this video I'm going to be talking about the robotic snowplow that I'm building. Basically what I'm doing is I'm taking a wheelchair frame, I'm adding a motor driver and making it remote control so I can drive it around with my remote, and then I'm going to add a snow shovel on the front, and using some of the actuators from the wheelchair I'll be able to move it up and down and stuff like that, and eventually get it driving around so I can plow my driveway from inside the house. I'll probably add some kind of GoPro or something like that so I can see what it's doing and utilize my Wi-Fi so I can feed images back and things like that. But for the scope of this video, I just kind of want to get the thing driving around and figure out how to attach the shovel to the front of the frame. I'm going to be talking a little bit about how you take a wheelchair chassis and then make it remote control, because there are a couple little things that you get into and a couple little things that you need to know. And for the beginning of the project, I'm using all these 3D printed components and some Actuator's channel because it's really great to prototype with. I don't really want to machine any components just yet because one, I don't know how this is going to work out, and two, I don't really know what the final design is going to look like. So I want to keep everything a little bit flexible for right now. And so yeah, let's first talk about the electronics. I'm using a really big LiPo battery to power the thing and my trusty receiver. So let's take a look at the wheelchair frame and see what I did to actually get it moving. So here is the chassis that I'm using. This is a Permobile Koala. I've had several frames over the years from wheelchairs. If you go on Craigslist and do a little bit of looking around, you can pick these up for pretty cheap. This one cost me $60 and it was basically in the condition that you see. It didn't have the seat or anything else, so it was really nice. I could just drop in and start using this. It has these two really big sim motors. These are 24 volts, so they work perfectly with the 24 volt system I'm going to be using. And they're pretty beefy, have a nice gearbox. I also like this one because they have these solid core tires, so I can drill some screws into this. I'm going to just use some big sheet metal screws and stud these tires so I can get a little bit more traction. And this is the back of the unit, which I'm going to be using as the front. So if you look here, we've got these two nice little attachment points. These are tow hooks. And then there's a few threaded tapped holes along the front as well. So I can use all these parts for attaching the shovel to the front. I'm going to be using these tow hooks as a pivot point for the shovel going up and down. The other thing I liked about this chassis was this big, wide open area. Most of these things don't really have a big open area for you to set electronics. They're kind of built into the frame, and the electronics themselves are weatherized. With this, I have this big open area that doesn't have any holes into it, so I can kind of weather seal this and make this the electronics enclosure. So that's pretty cool. The last thing I liked about this was it has this nice linear actuator, and I'm going to be using that to control the height of the plow up and down, or the angle, the pitch, whatever. And so it's a pretty cool little frame. It's relatively heavy duty, and if I flip it around to the back, these things are heavy. You can see that it's got this kind of pivoting thing with the casters on it. So it's a really nice little frame, and it gets moving pretty quickly, and I like it that it's relatively small because I don't think I could use a really big chassis with a huge plow in front of it. I probably just wouldn't have enough traction for that. So yeah, this will be nice to use. Let's look at the motors, because wheelchair motors are slightly different than what you might be used to, and there's a couple things you need to know before you start using the actual motors. Here is a wheelchair motor that's been removed from the frame. This is slightly different than the motor I'm using in the chassis over there. I just pulled this out of my bin of wheelchair motors just to give you an idea of what they look like and some of the things you need to look out for. The first thing you'll notice about this motor, the wiring harness, it has this little knob right here. Almost every one of these motors has two safety functions. The first of which is being a way to disengage the actual motor from the gearbox. So if you have a wheelchair that you need to push, it is really hard to push against the gearing of this, and sometimes there's a worm gear to where you can't press against it. So it's really hard to actually push the wheelchair. So usually you have this little lever or sometimes an electromagnetic switch or something else that will actually engage or disengage the gearbox from the actual motor so that you can freewheel, which means that you can just spin the wheel without being connected to the whole gearbox assembly. So if you're trying to run one of these, a lot of people I've seen on YouTube will pull one of these out, connect some voltage up to it, and the wheel doesn't do anything. They hear spinning, but nothing happens. And that's because you're not engaging the gearbox, so the motor's spinning, but it's actually not driving the gearbox itself. The other feature that these motors always have is if you look on the end of the motor, you always have some kind of electromagnetic braking mechanism. You'll see most of these have 4 wires coming off of the wire harness. 2 of them are from driving the motor, and the other 2 are for the electromagnetic brake. All the brakes look a little bit different, but I've never seen one of these motors without a brake. Essentially, it's a brake pad. It looks and smells a lot just like a normal brake pad, and there's an electromagnetic switch that either pulls it away or pushes it towards, and it basically just stops the motor from moving. And obviously that's a safety feature that if you lose power, something happens and you're going downhill, the switch will just disengage, it'll press against the brake, and it will stop the motor from moving entirely. It's a neat little feature, but for a lot of my applications I don't need it or don't want it because it's one more thing to suck up power. You can utilize the brake if you want. Just keep in mind that you're going to need to feed it 24 volts constantly to keep the brake open as long as you plan on driving things. Some motor controllers, I think like Robotic and the Sabertooth line from Dimensional Engineering, those actually both have outputs for the electromagnetic brakes. So if you're using one of those motor drivers, you can just use the outputs, go into the brake, and when the controller is on, it will turn off the brake or activate the brake, and you can drive the thing around. But I've seen people on YouTube take one of these, hook it up to 24 volts, they get the, this little lever engaged, so the gearbox is engaged, but it won't move, and it'll like shut down their power supply or shut down their motor controller because it's drawing too much power, and that's because the brake is engaged. It's very effective at stopping these motors from moving, so be sure to look out for the brakes. For me, all I do is disengage them completely. You can just undo whatever screws are on the end of this cap, and they usually just come right off. So for everything that I do, I just completely take them off because I don't use them. I use some kind of other safety mechanism that I'll go into later. The last thing that I want to talk about is if you're doing anything with these wheelchair motors, you're going to want to pick up some Anderson power pole connectors. I'll put a link down in the description of this video, but Anderson power pole connectors are pretty much the power connector that all of these motors use. These are a 4-bank inside of here, but if you go on Amazon, eBay, or wherever else, you can find power pole connectors, and they're really cool because it's the same connector for both sides, and they just kind of, they're mirrored images of each other. So they're pretty cool little connectors, and almost all of them are terminated with that. So if you're doing anything with wheelchairs, definitely get yourself a set of Anderson power pole connectors. Here are the basic components needed to get the wheelchair moving. When I say basic components, this doesn't include any of the other little fun accessories, like if I want to do a pan tilt on the GoPro, or if I want to do like some auxiliary lighting or other things like that, controlling the actuator. This is just for the 2 motors, just to get it driving forward and backwards. First up, I'm going to start with the battery. This is a really big LiPo. This is a 16 amp hour 6-cell battery, 22 volt. So fully charged, this is 24 volts, which is perfect for this application. And I've got that terminated with these XT60 connectors. That goes into this right here, and I've got this kind of cable set up to where it goes through this solenoid here and then into the RoboClaw. What I've got set up here is this is a Whites-Rogers solenoid. It's a 24 volt solenoid, and this is capable of 175 amp peak. So the thing is, you're driving this wheelchair around, and let's say you're really tearing it up, burning up the motors, and you have a really underpowered solenoid or relay, and it's going to fail. Well, it's going to fail closed. The contacts are going to weld in place, and then you're going to have a wheelchair that's permanently on in some kind of bad condition. So I have a really oversized solenoid here, and all this does is switch the current from the battery into the motor driver. That's all this does. And the 24 volts is fed through this little box and through the battery itself. And so all I have to do is this arms the system and disables the system. So this is just a nice little e-stop. I'm not using the key right now. I'm gonna come up with something a little bit more elegant for the final solution, but this is nice because if the chair is doing something silly, you can just come over and stop it like that. And all this does is prevent voltage from coming to the solenoid, so it turns off the solenoid and then no power flows through the system anymore. I have a better system that I made, but I accidentally fried it. I have a better system that actually uses an RC switch connected to the radio receiver, so you can control it completely remotely and also through the e-stop, and it has a separate battery backup, so if your main battery fails, you can still do some control logic stuff. So that's kind of what the battery does. It goes through here, through the solenoid when it's powered from this e-stop, then into the RoboClaw. This is a RoboClaw. I want to say this is a 50 amp per channel, which is totally fine for those motors. And it has a lot of really cool features. It's got a USB, it has encoder feedback, it's got some buttons and menus. It's a really cool, inexpensive controller. I have a RoboClaw, but that's like $300, a lot more complicated. This is just a nice, really simple controller. I think it's like 125 bucks from Servo City or wherever else you want to get it. And then I have my RC receiver right here. This is a 3-axis gyro complicated thingy. I might use some more of the features right there, but that's what I'm using for it. And you can see that I've got the channels from it connected into the RoboClaw directly, and I'm using the battery eliminator circuit from the RoboClaw to feed voltage to power this. So it's a really simple little system that when you connect the battery up, nothing happens. Undo the e-stop, everything powers up. You might be able to see the lights coming on right there, and as soon as I hit this, it goes away. So really, really, really simple, and you might be able to hear the contactor flipping on. Yep, and then off. So that's the contactor, so it's a nice big beefy switch for stopping your robot when something bad happens. So it dries nicely. Now I just need to attach a shovel onto the front of it. Attaching the shovel is a little easier said than done. Here's the shovel I got from Walmart, and all you have to do is unscrew here, and the handle comes out. So that was pretty easy. I specifically got this one because it was just the right size. The wheels come out like there and there, so it's ever so slightly wider than the wheels, maybe like an inch on either side. So the size is great. I didn't want to get something too big, as I said previously. The problem is it's really hard to find a shovel without all these grooves and features and stuff in it. You'd think you could get one that was just a scoop, but they don't really exist. So the challenge in attaching this is going to be, how do you actually physically attach this to a solid surface? So what I came up with was this. On the back side, you can see these kind of flats here that kind of scallop across. And so I'm going to be using this Actuator's channel, which is really great for prototyping stuff because it has all these holes in it, and it's a nice consistent hole pattern that you can attach stuff to. And I have these little 3D printed pieces. These are just kind of some quick prototypes I put together. And I attach them on the channel, something like this. And so what that gives me is the ability to do something like that. So let me show you a little bit better from the side. So I'm kind of attaching here and here, and so that gives me a nice flat rail surface. And if you look at this from the front, you can see that if I attach to this one over here and this one over there, it gives me a nice parallel surface to the side of the shovel. So I'm going to do one like this and one like that, and that'll give me a nice surface to attach to those front tow hooks on the front. So let me get a close-up and show you what exactly this looks like. This is a 9-inch section of the Actuator's channel. I have a little short arm, and then I have a longer arm. Both of these were printed in my 3D printer, and they have holes on the end right there. These have yet to be tapped out or threaded for the mounts on the shovel, but I just need to run a tap through those. And you can see that they have openings that correspond to the openings on the Actuator's channel. And then they have these little spacers that fit inside the channel like that, and then they also fit inside there, so that when you put this in there, that goes in, and that's kind of what secures it, and that's what allows it to pivot. And then if we look at the finished one, I've just got a screw that runs through the spacer, through this block, and on the other side I have a nylon lock nut. So you can tighten this as tight as you need, and these have a little bit of flexibility, but not a ton, so it allows, you know, just a little bit of wiggle room for this whole thing. And for these are already tapped on here. There will be some rubber washers that sit between this and the shovel, and then between the screw that goes into the shovel and the shovel itself. So yeah, this is the little bracket. So I'm going to go ahead and show you how I kind of finish off and process these once they come off the 3D printer, and then I'll build one of these second assemblies. Even though the mating surfaces came out pretty good from the 3D printer, I just need to clean them up a little bit. So for the little attachment arms, I'm using a 1/2-inch drill to drill out to the inside to make sure that it's a true 1/2 inch. After I get that done, I need to take the little spacers or little shoulder washers on the outside and then make sure that the outer diameter matches the 1/2 inch that I just drilled on the other arms. So I just take a little screw, put that through the middle, tighten it down, and then essentially use that like an arbor on my drill, and then with a file, I can actually file it down and make it nice and smooth. Now that all the mating surfaces are cleaned up, it's just a matter of assembling everything together. I take the channel, lay down the arms on the inside, insert the shoulder washers, put a screw through, flip it over, add the other shoulder washers, and then attach the lock nuts to the other side. I want to make sure that it's tight enough so that everything isn't, you know, super loosey-goosey, but at the same time I don't want it too tight to where it's just crushing everything. So the lock nuts are really nice. We're just kind of adjusting it to the exact level of tightness that I need. Now that the rails are built, it's time to attach those to the shovel. The first thing I need to do is figure out exactly where the holes are going to go. This was kind of a process of trial and error. Ultimately, I just kind of found out where the spacing horizontally was going to be, marked that out with some painter's tape, and then, you know, drew some lines, just kind of figured that out. From there, it was then determining vertically where these holes were going to go. As it turned out, where I thought they were originally going to go wasn't a good place because the rails were going to be hitting down on the ground when the shovel lifted up. So I kind of had to go back and forth a couple times, and I used some of this double stick tape just to attach them on there, bring it over to the chassis, kind of take a look at it, see how everything worked out, and I just kind of iterated back and forth. And then when it was finally time to drill, I drilled the bottom 2 holes first, attached all the rails that way, and then just kind of marked where the top locations were and drilled those blind. So that worked out pretty well, and it's kind of cool to see the rails on there, and they have a little bit of a give to them because of all the rubber washers. So yeah, that actually worked out pretty easily. Now that I have the brackets attached to the shovel, I need a way to attach those brackets to the frame of the wheelchair. As I said before, I'm using those tow hooks on the front, so I printed out these little brackets right here. So they have this little kind of clamp mechanism with these 4 bolts, and you can see there's a groove or a slot right there. So that ties directly in with the tow hooks, and this kind of clamps on the tow hooks. It sits a little something like that, and then it allows it to move up and down. And so the only real problem with this is that these are movable. I can secure these a little bit better and tighten this down, but I might need to print a slightly different design so that they stay in a fixed position like that, and then I can use the actuator to move it up and down like that. Once again, this is all just kind of prototyping. I really have no idea how this is all going to work out. I don't know if it's going to hit the first like tiny little crack and just explode everywhere. Maybe that's what's going to happen. Most likely that's what's going to happen. These are also way too thin. I kind of made them to be a little bit brittle. I just wanted them to print really quickly so I could try some things out. But most of this is a moot point until I can get the actuator lifting the actual shovel up and down, because the height of where the shovel is going to be critical, as well as the angle of the shovel. So I just kind of need to get something on there so that I can kind of tweak and adjust where all that is for now. So this is a good way to just kind of get the shovel on there, and I can wait for it to snow, because it only snowed once so far this season, and we kind of need some snow to be able to test this. But once I get this on, we get some snow, I'm going to play with it a little bit, see how it works, and then I'll work on getting the actuator set up. And then once I get the actuator set up, then I can kind of tweak and iterate a little bit. But I think this is a good shovel. This is a good attachment method for the shovel. I just need to figure out how to get this attached to the actual chassis and then get all the controls working. So that's it for this video. Thank you for watching, and stay tuned for more updates on the Stratasys rebuild as well as the robotic snowplow build.